All right, so in this example for hypothesis testing, we're going to run a means test, but we know the population standard deviation. So Jeffrey, he is an 8-year-old swimmer. He has an established mean time of 16.43 for swimming the 25-yard freestyle and a standard deviation of 0.8. So that established mean means that his true population mean is 16.43 and his standard deviation of all his swimming times is 0.8. His dad gets him some new goggles. They want to see if these new expensive goggles will bring down his time. So he uses them for 15 swims. So that's our sample size. And the mean for that was 16 seconds. Okay, is this significantly faster? So again, mu is the true average time of 25-yard freestyle. Excuse me. And I need to set up my null and alternative hypothesis. Well, what am I trying to prove? I'm trying to prove that the mean is less than his established mean. And so the opposite of that is my null hypothesis. And I'm going to center my distribution at that null hypothesis value. And then I want to do this at a 0.05 significance level. So my rejection region for an alpha of 0.05 is going to be right here. Now, if you look in your normal model chart, and I can use a normal model, I can use a Z distribution because sigma is known. And so if you go look in your normal model chart and you try to figure out what is that Z value that gives me that rejection region, that Z value is going to be negative 1.645. All right, so I want to know, is 16 that sample mean, okay, in this rejection region? Well, I need to find the Z-score for that sample mean, and I do that using the sampling distribution. That is very, very important that we still remember. We're going to use the sampling distribution in order to find this Z-score. That's going to then give us whether or not we're in this rejection region using the critical value. We'll also find a p-value associated with this as well. So we're going to go ahead and do this in StatCrunch. I have that pulled up here. And we're going to go under Stat. We're going to go under Z Statistics, one sample, and we have the summary. The sample mean was 16. The population standard deviation was 0.8. Sample size of 15. Now I'm testing, notice the default here does say equal, that's okay. And I want to run my test to be less than. Let's go ahead and show that critical value, make sure that I'm correct here with the significance level. And I wonder what happens when I choose the P plot here. Notice you didn't see that whole thing. And I'm going to say compute. All right, so notice here, it's all the things that we have written out. The standard error is 0.08 divided by square root of 15. This is the associated Z statistic. So if I go back to my notes, my Z statistic is negative 2.08. Notice that that is in the rejection region. Okay, negative 2.08 is in that rejection region. Additionally, it gives the critical value right here, and that p-value is 0.01, which is less than the alpha value of 0.05. All right, let's look and see, what does this plot look like? Yep, it shows right there. Now, notice here it shows the actual z-score and p-value. It doesn't give the rejection region in this one. It shows like the actual normal model for this situation with that z statistic under there. You can kind of do it two different ways. I prefer showing the entire rejection region and then showing that your z-score is in that rejection region. All right, so we are able to reject the null hypothesis. There is sufficient evidence that the new goggles decreased swim time. So they were worth the investment.